What's poppin', dogs? Mr. Allen here. We're about to solve this quadratic inequality. Woo! We got a lead coefficient here. There is no GCF in this bad boy, so I am factoring with a lead coefficient, and I know how much you guys love that stuff. So I got to multiply to positive 40, and I got to add to 13. What two numbers are going to do that? That's going to be 8 and 5. So I'm going to have 4x squared plus 8x plus 5x plus 10 is less than or equal to 0, right? That adds up to 13. I just broke apart that 13. So now I can do this with factor by grouping, which is, I like factor by grouping. It's a pretty simple process because you're just looking for GCFs in two terms. Here would be 4x, and I'm left with x plus 2. Over here, it's going to be a plus 5 is coming out, and I'm left with x plus 2, less than or equal to 0. And then we have 4x plus 5, and we have x plus 2 as my two factors. Now I got to find out when these equal 0. Those are going to be my key points in solving this inequality. So I'm going to have x equals negative 5 over 4, and I have x equals negative 2. Now that's not my solution there. I got to figure things out with these 2 points, and I can do so by either using a sign chart or by graphing. So I'm going to show you guys both. All right, first one, sign chart here, and then we'll show how the graph agrees. All right, so if I do a number line here, I got negative 2, that's going to be my smallest number, and I have negative 5 over 4, so negative 5 over 4. I don't have like a 0 here for reference. I just have these 3 different sections, okay? So if I'm going to test a number like negative 2, or sorry, less than negative 2, that's going to be something like negative 3, okay? So if I test out negative 3, and I plug it in here, I'm going to have a negative number here because it's negative 12 plus 5. I'm not concerned about the actual value, just that it's negative. Over here, it's going to be negative. 2 negatives, that's going to give me a positive overall. Now, in this one here, what's between negative 2 and negative 5 over 4? That's like negative 1.25, so like negative 1.5. Ooh, that's a little rough right there. Well, when I plug in negative 1.5 here, I'm going to get a negative number, okay? But when I plug it in here, I'm going to get a positive number, okay? So it's a negative and a positive. Overall, that's going to be negative, right? I'm not concerned about what that value actually is, just that it's negative here, it's positive here, overall negative. Now, I'm going to test out how about like 0 here. If I plug 0 in, I'm going to get a positive and a positive. 2 positives, dogs. That makes it positive overall. So to answer this question here, when is it less than or equal to 0? That's in this middle section when it is negative, right? Less than is negative, equal to is 0. So I'm going to have one of 2 ways of writing this thing. I can either say negative 2 is less than or equal to x, which is less than or equal to negative 5 over 4, or we can use interval notation, and we'll be using brackets in this case because we are including the values. Negative 2, negative 5 over 4, bracket, bracket, that is dope. Let's see how the graph would agree in this situation. What we'd have here is a lovely little quadratic, right? So we got negative 2, so I'm going to go like this. There we go, negative 2. And it's negative 1.25 roughly, so it's going to be like right about here. And I'm going to have something that looks like this. Woo! Beautiful. And as we can see, in that middle section right there, in this little section right here, that's when it's below the x-axis. It is negative, and at those 2 spots, it's equal to 0, which is why we included them. Same solution. I think the graph, honestly, is a little easier in this one than the sign chart. Either method works. Pick your choice. That's dope. It's awesome. That's fantastic. I will see you dogs later.